Hello, this is Victoria Maldonado. I'm going to be talking about how I trained and evaluated my DeepRacer car using deep reinforcement learning. I'm going to be talking about the steps that I took to train my AWS car. So basically, I first had to define a strategy, then pick an environment, then decide on the hyperparameters and the reward function. After that, I was giving my evaluation results and the ranking. And lastly, I'm also going to be showing you a little bit of a screen recording of my training and the observations. So my training strategy consisted of making sure that the DeepRacer works. I had about 7 tester cars, and then I made some changes to hyperparameters in all of them. And I'm going to be explaining more about that later. And then I improved the reward function by basically increasing the rewards when the car stays on track, it's close from the center, and it has good speed. And then also decreasing the reward when there was too much steering. And finally, I increased the training time of my last car to 100 minutes to improve learning. A little bit about the environment that I chose. We were required to choose the reInvent 2018 white. Here's some information about the track. For the hyperparameters, here's a screenshot of the hyperparameters that I've been using. I'm going to explain a little bit more in the next slide. So these are the hyperparameters that I chose. You can stop the video to read more about them. But basically, I chose 256 for the gradient descent badge size. I chose 5 for the number of epochs, 0.0005 for the learning rate, and 0.05 for entropy. Some other hyperparameters that I had to choose were the discount factor, and I chose a 0.999 for that one. And then for the loss type, I kept it as the default Hubert. And then for the number of experience episodes between each policy updating iteration, I just left it as the default 20. So this is a screenshot of my reward function, and I am checking for a lot of stuff. But basically, I'm given more rewards if the distance from the center is reasonable, and also if all the wheels are inside the track. Then I'm penalizing the AI a little bit if the steering is excessive, and then I am also checking for the speed. And if the speed is more than the minimum desired, then I am increasing the reward. So here's a little bit more information about the reward function. And one thing that I didn't mention is the only stopping condition that I have is the time limit. This is just my reward graph. As you can see, it's very interesting how it started improving a lot after iteration number 5. So after training, I got what's called the evaluation results. As you can see here, it completed 100% of the track all the time in each iteration, but the time is not as optimal. It took about 23 seconds to complete, which is pretty slow, and I would like to improve that. So basically my ranking was 351 out of 424, which is not terrible, but it obviously can be improved a lot. So here I'm going to play the screen recording of, I think, the 3rd training that I did on the 3rd model. So yeah, I really like to see how the AI explores and fails and learns. But as I'm going to talk about in the next slide, I think a big problem is the turns. All my models have been having problems with the turns, and I definitely need to improve that. And yeah, observations. So I talked about the improving the turns part, and I also want to mention that I really need to focus on the speed, because once the AI learns how to stay on track, which is about in the 10th iteration, then the problem becomes the speed. So this would be all for the video. This is just a link that I have for the hyperparameters information. And yeah, thank you for watching.